right, so as far as this goes, we have, yesterday we talked about, inverse functions with graphs. And we're going to recap what we learned. So yesterday we learned that it needs to be 1-to-1, which means it passes the what test? And passes HT and VT. Is that okay if I write that and you all know what that means? Alright, so horizontal and vertical line test. And if the original function does that, then we know that its inverse is a function automatically without graphing it. Alright, next is the symmetrical. When it says symmetrical, that means that this is my line of reflection. So I have a line of reflection. So when I look at this point, it's being reflected. Alright, the domain of F is the range of the inverse, and the range of F is the domain of the inverse. Remember we talked about how the domain and range end up switching? And then the last thing, which is, I don't think I really went in depth about, so it's kind of be new, is this aspect. The reason why we need to learn composing is because this is how you verify inverses. You verify inverses by composing them. So remember, this is composing. Alright, so I compose the original function with the inverse, and my answer should be x. If I compose the inverse with the original function, my answer still should be x. Which means everything cancels out but x. Write it. Okay, so everything will cancel out but an x variable, and that's literally one x variable. Alright, so from Algebra 2, I was hoping that you guys would remember to find the equation of inverse given function. You replace f of x with y, you switch x and y, and then you solve for y. So this is how you solve algebraically. Now algebraically, is it I? Algebraically. Okay, so solving algebraically. We're going to be focusing on this today. Alright. It's spelled right there below. And I'm over struggling. Alright, so this is our first function we're going to look at. On your homework last night, you actually should have dealt with this function. On number 5, 10, 11, and 12, the opposite of a quadratic is a square root. So if you got that for 5, 10, 11, and 12, then you got the right answer. If not, then hopefully you tried and put something. Okay, so the first thing we're going to do is graph the quadratic, the square root. So this is a square root. And so we're going to graph it. Well, we know that this means that our function was, what happened to our original function? It was shifted to the left 3. So if we came up with our parent function, the parent of f of x, which is square root of 0 is 0. Square root of 1 is 1. What was our next perfect square? 4? 4 and 2. And then our last one was 9 and 3. Is that right? Square root of 9 is 3. Alright, so those are our parent functions. What are we going to choose to each one of these x values? Shift them to the left 3. So I'm going to graph them and shift them to the left 3. So 0, 0 is being moved to negative 3, 0. Alright. 1, 1 is being moved to negative 2, 1. Is that right?
Yeah.
Alright. 4, 2 is being moved to 1, 2. And 9, 3 is being moved to 6, 3. And that is my new function that will go on forever, right? So can we establish the have y'all realized how everything is now tying together? We just did a transformation. We just talked about parent functions. We just went over composing. All of this comes together. What is the domain? -3 to positive infinity. What are my endings?
Bracket and a parentheses.
Bracket in a parentheses. All right, what about range?
0, 0, 3.
And what is my bracket in a parenthesis? All right, inverse tells me that I can take this function and I would do what?
Switch the X and Y.
Switch the X and Y. Well, let's do that. So this is going to tell me, so we're going to switch X and Y. But does this tell me I can do it graphically, but will that lead me algebraically yet? No, we actually have to work it out, right? So which do y'all want to do first? Do we want to switch X and Y first, or do we want to do algebra first? Algebra first. Thank you for giving me an answer. All right, so doing algebra first, we're going to do it at the bottom of our page. I think I left you enough room. Did I leave y'all enough room?
Yeah.
All right, so our current function is f of x equals the square root of x plus 3. So we switch this to become x equals the square root of y plus 3. How do I cancel out a square root?
Square root.
So I square both sides. So what I do to one side, I have to do to the... So now I have x squared equals y plus 3. How do I get y by itself? What I do to one side, I have to do to the... So my final answer will be f of x equals x squared minus 3. Do we understand that part? So all we did was work backwards. And now we have our inverse algebraically, just like we did on the warm-up yesterday. All right. So we now can graph. Well, we know that this is what function?
Quadratic.
The quadratic, right? And this quadratic was, what happened to it?
Shift to left 3.
X squared minus 3 is what? Down 3. Okay? Because it's on the outside. Is it with the x? No, it's by itself. So we know that our parent function has been shifted down 3. Well, let's try using these points and see if that's to happen. So instead of being at -3, 0, where do I go? No, my x and my y's are currently -3, 0. If I was to switch them, what does that become? 0, -3. So now I'm at 0, -3. This is at 1, 2. So now where will I be at?
2, 1.
So 2, 1. This one's at 6, 3. So now I will be at 3, 6. So I'm going to go 1, 2, 3. Oh, it's right here. All right. Well, I have half of my quadratic. Do I have the other half?
No, because it's a square root.
I don't, because it's a square root. And this is a restriction, right? There is a restriction set on my function in order to make this possible. So this was possible because of restriction. I ran out of room. Right, restriction. Okay? So this was possible because of restriction. Well, can we figure out the other points that we're missing? Aren't they just a mirror of it? So instead of at 2, 1, this is going to be at -2, 1. Instead of at 3, 6, is going to be at -3, 6. And now I just have to try my best to connect my points. And now do I have my full quadratic? What's the domain of the quadratic? Negative infinity to
Positive.
And for this quadratic, what is its range?
-3.
And notice that my range is
Y.
The domain.
the domain of the original. Okay? So why did I have to have a restriction?
Because there was.
How about
It had 1 to 1.
it made it 1 to 1, right? Quadratics do not pass 1 to 1, do they? No, because I'm going to hit how many points at a time? 2 each time. So in order to have an inverse, its inverse must have a restriction. So its inverse must have a restriction in order to work. So, quadratics and square root are inverses with restriction. Because quads are not what? 1 to 1. If I just write 1 to 1, is that okay? Do I need to zoom in or can y'all see it? Can everyone see it? All right, any questions about this front part? So we used everything we've learned over the past 2.5 weeks in one problem. Crazy, right? Yep, I know. So we're going to go on to the back. Now, this is a what kind of function?
Rational.
Rational. Why is it a rational?
Because it has variables
A variable where?
in the denominator.
And the denominator. I have a variable in the denominator, which makes me a rational. With a rational, you should be able to identify its asymptotes. So we're going to identify asymptotes and then draw a sketch. So we're going to graph this. When I graph it, where do you notice my asymptotes are at? I have one at -3, right? And then where's my horizontal asymptote?
2.
At
1.
2. All right, so can we draw those in? And then sketch our graph. So we're going to draw in a vertical asymptote at -3. Is it at -3? And a horizontal asymptote at 2. All right, so those are our asymptotes. Mine are kind of thick. And now we just sketch it around. So the function was doing something like that and doing something like that. Can I now describe the domain and range?
Yes.
What's the domain of this function? Left or right?
Negative infinity.
Negative infinity to,
Negative 3.
and then what happened?
The u.
Then, boys, you have a question? Brandon, Tristan, any question? All right, what's the range? From bottom to top.
Negative infinity to 2. And then 2 to
Union. 2 to
You're only going to use that union thing on rationals, right?
typically, yeah. Yeah. You use it in both on rational. All right, so now it says to find the inverse. So in order to find the inverse, we got to switch who and who?
Grab the main range.
X and Y. So switch X and Y. So we're going to switch X and Y. So down here, I'm going to write X equals, is it 2Y plus 7 over what? Huh?
Y plus 3.
Y plus 3? So our goal is to get Y by itself. So we have a lot to do to get Y by itself. So the first thing is I need y to be in a numerator. So how can I get y into a numerator? Multiply. What I do to one side, I have to do to the. So multiply by 1y plus 3. On this side, I'm going to multiply by. I ran out of room, but you get it. So y plus 3 times x equals 2y plus 7. All right, we're now out of the denominator. What do I do here? Combine, which means to distribute, right? So I'm going to distribute, and I have xy plus 3x equals 2y plus 7. All right, I almost have them all by themselves. Now what do I do? Subtract 7 from this side. What am I going to subtract from this side? xy, right? Because it has a y on it, so it needs to move to that side. All right, so now I have 3x minus 7 equals 2y minus xy. Let's see how good your algebra skills are. Do I need to do anything else to this side?
No.
What do I need to do to this side?
Take the x and 2 out of there.
Okay, or just get the what out of there?
Y.
I can factor out y, right?
Yeah.
So when I factor out y, what am I left with? 2 minus x. So how do I move 2 minus x? Divide. So our new inverse is
3x minus 7 over 2.
beautiful. So I'm going to be lazy and just copy it. Copy. I hope I pressed the copy button. Paste. What? She did it. She didn't mess up. All right, what do you notice about our inverse and our original function? They're almost the same, but a lot happened. A lot of changes happened. A lot. All right, so what do we need to find again? Our asymptotes, right? Because it's a rational, and rationals have asymptotes. You know, I'm going to use a calculator just because we can. So I'm going to put my new function in the calculator, 2x minus 7 over 2 minus x. So tab, control, divide, 2x minus 7 over what?
2 minus x.
Is it x 2 minus x?
It's 3x minus 7.
Thank you. I was like, that didn't sound right. That correct? Where are my asymptotes at now? So my asymptotes are at what?
3 and 2.
Negative 3.
Negative 3 is my what asymptote? Horizontal. And positive 2 is now my vertical. All right, so where's my horizontal at? Negative 3.
So they just switch?
So now, do you see the pattern with rationals? So what happens with rationals? Their asymptote switch, right? So the inverse of a rational, their asymptotes are going to be the opposite. So we're going to go ahead and sketch that in. Did it look like this? It was like this, right?
Mm-hmm.
So if you work a rational and your inverses don't come out the opposite, what does that mean you did with the rational? You messed up, right? You did the problem wrong. All right, so what's my domain? It's the what of my original?
Range.
It's the range of my original. So it's from negative infinity to 2, 2 to,
Positive.
and then my range is my
Domain of the original.
All right, so let's now write what we learned about rational. So the summary of rational. Inverse of a rational has different asymptotes. I think that's how you spell it. So f of x vertical asymptote becomes inverse of x horizontal, and so on and so forth, and so on and so on. Alright, so the inverse of a rational has different asymptotes. F of x vertical asymptote becomes the inverse horizontal asymptote, and therefore f of x horizontal asymptote becomes f of x's vertical asymptote. Alright, how do we feel about them? These are the two most difficult ones for people to understand. Everything else works normal except quadratic and rationals. Other than that, you just end up solving for y and graphing new functions. So these are the only two that we really need to cover.
Rationals are easy.
Yeah. The asymptotes.
Good morning, teachers and students. Please find this interruption for this
And
morning's
that is it.
announcements. Please stand for the pledge. Allegiance to the flag of the United States of America and to the republic for which it stands,